Okay, welcome back. This is the third video in the series. In the last video we defined three core classes. In this video we're going to test them by running them through a few scenarios. So we've got a couple of scenarios up here. Now the first one is Elon Musk a VIP customer? Okay, so Elon has three accounts: a personal account, a SpaceX account, and a Tesla account. So what's his total balance? We need to know if it's over $1 million. Okay, so in terms of objects, I've got three account objects for Elon. Now, who do I ask for the total? Do I ask the personal account, the SpaceX account, or the Tesla account? So the reason I say that is because the account is responsible for calculating the total balance. So I've got a bit of a problem here because I've got three account objects, so which one does it? So the question is, should one account object have access to another? Well, no, I don't think so. Alright, so the analogy I like to use is, for object-oriented design, is employees in a company. So the idea is that every object is like an employee, and each object, like an employee, has a single responsibility. Now, they're also organized into a hierarchy. So you've got the CEO at the top and then lots of managers down to the employees at the bottom. And they all have a different scope of responsibility and a different scope of access to information. So if I wanted to find out, for example, how many pencils the company sold this month, I could go to the CEO and ask him or her, but that's not very appropriate. Certainly she has access to all the information to answer that question, but it's not appropriate. So what I should do is go down the hierarchy to an accountant, perhaps, and ask an accountant, how many pencils did we sell this month? And they have enough scope of information to answer the question. Now I could go lower to somebody who doesn't have that scope of information, and that wouldn't be appropriate. So the idea is we have to find the appropriate level of access to delegate responsibility to. All right. So with that analogy in mind, let's think about our accounts. Now, who or which class has the right scope of information to access all of the accounts for one customer? Okay, so one customer is the key. So that gives us a hint. So one customer has a list of many accounts. So Elon Musk would have Elon Musk customer object would have a list of three account objects. Perfect. It's exactly what we need. So we need to iterate through those three accounts to calculate the total. So who has responsibility of that? To do that, the customer. All right, so let's move this responsibility. Let's edit that. So you edit that and we will move this responsibility of calculating the total balance from there, and we'll add it into the customer, like so. All right, so now the customer has responsibility for calculating the total balance. All right, now in our real scenario is Elon Musk a VIP customer? So the only person who can answer that question really, again, is the customer. So what we really sort of want is to be able to ask that question and get an answer. So determine VIP status would be the responsibility. If you wanted to, you can go a bit further and define some methods. It might be called isVIP, which returns a Boolean, something like that. Okay, so you can start designing a little bit of your attributes and methods at this stage, but don't do too much. Just keep it minimal, things that are relevant. All right, so we fixed one problem. All right, so that scenario was helpful in finding a problem that we fixed. Okay, let's look at this second scenario. Deposit $50 into Elon's account. All right, so I guess he needs some help to reach that $1 million threshold. Let's give him $50. All right. So which class is going to be responsible for this? The Elon object. Then we've got 3 accounts. We don't know which one to put it into. So we really should go to an account object. And okay, so how are we going to deposit into the account? Well, we could have some sort of a method like deposit. So just for example, deposit 50, that could work. All right, and we also need to create a new transaction object because we're doing a deposit transaction. All right, so we could have a responsibility in here to create transactions. Not sure about that. All right, so let's think about this a little bit. All right, so there's a few things we've got to do. We've got to update the balance. Clearly, the account is responsible for updating the balance because that's an attribute inside it. And we've also got to create this transaction object. So there's a couple of ways we could view this. Either we create the transaction first and then do the deposit, update the balance, or we do it in the opposite order. Now, if we create the transaction first, we've already got an object which stores the amount of the transaction and everything we need to know. So it would sort of make sense to have a perform or a run transaction method that takes a transaction. So we create the transaction object first and then perform that transaction on the account, and then it updates the balance. That could work as well. All right, so we've sort of got 2 choices here, perform transaction or deposit. So in the other choice, if we had a deposit method, well then that one would probably need to create a new transaction object. Right? Right, so in this case, in this second case where we deposit and then we create a new transaction after the fact, the transaction object is just sort of like a record. It's just a log, a journal of what has happened. Okay, so we've got 2 choices here. All right, now I'm going to go with the second choice with, well, let me say they both have advantages and disadvantages, but I'm going to go with the second choice. The reason being is that I see it as a safer choice. There is a chance that we could, in this section, when we create the transaction and we add it to a list, assuming we have some sort of a history of transactions run on this account, there's a chance we could add it to the history list, and then after that, before we update the balance, it might fail. And so there's this greater chance that for data integrity problems. So I like this method better, where we just, and it's a bit more readable and understandable to programmers using this account. We're just depositing some money and we're hiding the information about transactions in the background. So the client of this account doesn't need to know anything about transaction objects. All it needs to do is call the deposit method, which is hiding more information. That's encapsulation. That's good. So there's less coupling. So I like this first approach. So let's get rid of that, and we'll put this, yes, we're going to create transactions as a record, and we're going to have our deposit method just, for example, there, and that would be an integer or something, deposit some integer. Okay, so that gives us a better idea of how this is going to work. All right, so we'll save that and take a look. All right, so now we had, so that looks good for account. We also had in transaction, run the transaction. So we're no longer in need of that. So we'll just edit the transaction object, get rid of that responsibility. Okay, so it's just purely a record now, which stores an amount and a link to one account. So that's purely an information expert class, and this one has the responsibility for updating the balance and creating the transaction and keeping a history log if necessary. Okay, it looks good. So that's enough to give you an idea of how to brainstorm object-oriented designs using CRC cards. Alright, if you find these videos useful, let me know in the comments section below. And we may be able to do some more of these videos in this series and finish off this little project. Okay, thanks for listening.